So I guess we can almost begin. And today I'd like to introduce you to my colleague, Bin Qian. She's a backend engineer with the TikTok Global Live Money Platform team. So you would have learned from Shijun on day one. She's from his team. And then now I will allow Bin Qian to introduce herself and then to walk you through today's session on cloud native microservices with Kitex. Welcome, Bin Qian. I'm sorry, wait, hang on. I accidentally muted this, the mic. Okay, now you're good. Thank you.
Okay, hi everyone. Thanks for joining this session. My name is Bin Qian and I'm under the Money Platform team in TikTok. And I work on the, sorry, unmute myself. Am I audible? I should be audible, right? Hi. Hello. Oh, okay. Okay. Let me continue to introduce myself. So I have been working with TikTok since March 2021. And currently I'm handling the in-app purchase system of the TikTok Live application. And I graduated from NUS some year back ago. And I have been living in Singapore for over 15 years. Yeah, that's a brief introduction about myself. Motomi, am I good to start sharing the screen?
Sorry, yeah, they all can hear you. You can go ahead and start your screen.
All right.
Thank you.
Go ahead. All right. So my section is about the cloud native microservice with Kitex, and yeah, I have briefly introduced myself, some simple points over here. All right. I see somebody raised the hand. Should I move on?
No, just move on. I will handle that. Sometimes they accidentally click it. It's okay. We'll handle that. Yeah, no worries. Go ahead.
So I will move on
to
today's topic. So basically we will be briefly going through the 4 parts. So first part is about why microservice in the industry. You might be heard of this word very often, but you might not get the idea of why it is better and what is the traditional ways that we have to shift from towards the microservice direction. And for the second part, it will be some basic concepts of the RPC core. I will explain what RPC stands for in the section later. And for the next part, it will be a brief introduction to the Kitex framework. And also, lastly, followed by some industry examples, so we can see how is the concept being applied. All right, let me move on to the next slide. So for the first chapter, traditionally, the industry has been practicing the monolithic architecture, but nowadays, the architectures are more shifting towards the microservice architecture. And also, I will be introducing the components in the microservice service system, and also what are the benefits compared to the traditional way. So first, let us look at what the history practice is. So this is a simple diagram that illustrates a very simple service of the monolithic system. So basically we have a client. The client can be your mobile phone, your PC, and your personal devices. So how does your client interact with the system to serve the business needs? So the client will interacting with network layer, and I will just be simply putting it as a box for reverse proxy. So the proxy will be sitting in front of the actual backend service deployed. And you can see that in here, we have an entire box. The whole chunk is a single service and it serves everything. So that is the traditional way. So what are the cons of the traditional approach? So basically, I have summarized the factors here, the 3 points. First, the monolithic system is vulnerable. So as you can see that the entire service is deployed as one, which means if any failure in the code of the service, then the overall system will fail as a whole. So for example, in the TikTok app, there are a lot of functionalities. Users can watch live and also sending the gift to host. Let's imagine if the two functionalities were served by a monolithic service, whenever there is an issue within one of the function, the other would fail as well, which means if there is an outage in the gifting system, you can't watch live. However, with the microservice approach, the two functionalities are separated. So this is the first point. And the second point is the system is hard to scale because it is bulky. So first, imagine you have to provide everything in one service. That means your code base will be very large. And normally we will have multiple teams maintaining each different functionalities. That means they have to work on a single gigantic code base, which also means there will be a lot of code conflicts and hard for the system to evolve. And for the third part is about coupling. So since the service is all in one, that means everybody has to use the same language, the same technology, and even the same framework. It's very hard to evolve the technical version of the REPL. So for example, I'm on a very old language, let's say Java 8. But now I wanted to shift to a new language. I can't do that unless I change everything in the REPL. So which means most likely the REPL will have to stay on a legacy technology. And also change in one component might impact the others unintentionally. As the code base continues to grow, you might lose track of how the code affects each other. And it will be very hard to test out the system as well. So for nowadays, people are moving on to a microservice architecture so that each of the functions can be managed individually. This diagram illustrates how a typical microservice system looks like. So basically, we still have the client, but now the client interacts with an API gateway. The API gateway is somewhat similar to the reverse proxy that we have elaborated in the previous slides, but will be more functions available on that. And also behind the API gateway, we can see that now the big box is broken down into individual services and each serving a different functionality. And the services can have separate storage to just manage its own business needs. And how does the request know which service to hit? So I have put up a simple example over here. So let's say on the API gateway, we configure the different HTTP paths. So I can route all the requests to a certain path to my service A, and for the other path, I route to service B. So if I want to send gift, my path could be named as /gifting. So the request will go to my service gifting, so on and so forth. And also we can have a service dedicated to expose some management API for the DevOps to do the daily maintenance and troubleshooting with the system. And also because we are having so many services being deployed, we will need a management or the orchestrator component to support the infra level deployment. So next, let me move on to the components. For the orchestrator that we talked about, it mainly manages the deployment. So it's in charge of placing your services on the nodes. The nodes here is referencing for technologies such as the virtual machine or physical machine, or even the Dockers that you might heard of, which is very popular nowadays. And also the orchestrator is in charge of detecting the failures. Whenever there is a service that fails on a particular node, or the node has something wrong, might due to physical corruptions or resource constraints, the deployment manager should be taking this node out from its pool of node and stop deploying, and also sending the workload to this malfunctioning node. And also the orchestrator need to be in charge of rebalancing the service only nodes. So because the nodes are running different business services and each might have different intents of the workload, that's why this node resource consumption will be uneven. So the job of the orchestrator is to even out and also try to utilize the resources as optimal as possible. Some of the popular technologies that the industry adopts nowadays are Kubernetes and Docker, that some of you might be familiar with. Then for the API gateway, it serves as a single entry for the client and a unified facade. So what is the benefit of using API gateway? It decouples the client from the service, such that whenever there is a change in the service API, the same API can still be exposed to the client without the client knowing that, knowing the backend changes that's going on. And also the client does not need to know the routing logic. Like, for example, when sending the gift, the client just hit the single point with the path, but you don't have to worry about resolving to the actual backend service that serves the workload. And also, the API gateway will be containing many cross-cutting functionalities. Some common examples given here are authentication. We need to verify who the user is. So how do you think the app knows who are you? So after you, let me just explain a very simple scenario on how this is implemented. So basically, you will be going through a login process, 2FA or so whatever with your favorite Face ID, password. Yeah, so after the login, the system will issue a token to your client device, which is encrypted or signed. And then this token will be coming along with every request that is fired from the device. And on the API gateway layer, it will centralize the logic to pass the identity from this token itself and continue to send to the backend services, so that all the services sitting behind the API gateway does not have to implement such common logic by themselves. So this is one of the example. The others is like SSL offloading. So you know, nowadays we are on HTTPS, which is very secure. So that because it is based on the SSL, so all your communications are being encrypted. However, this also introduces more load for decrypting the request, and that's why when communicating internally, we want to offload this extra workload. So this is done at the API gateway layer. And the next example is about load balancing. This is somewhat very similar to what the reverse proxy provides. So we have a lot of backend services deployed as replica set behind the API gateway. So it will have to send the workload to each of the instance to make sure that there is no hotspot. And the API gateway will also be providing some out-of-box functionalities based on very specialized needs, such as throttling. So throttling is features. For example, if there is the API it has serves very heavy load and you want to limit the rate of the request being accepted. So this can be done at the API gateway. Let's say my API is only allowed to serve 10 requests per second. Then I can configure on the gateway itself to reject the rest if the limit is exceeded. And also some other functionalities are like caching. If there is a very frequently queried API where the content is somewhat static, then the API gateway can just cache it in itself without hitting the backend service every time. And also transforming. So the communication protocol between the client and API gateway is not necessary to be the same as how the API gateway communicates with the backend services. So for example, the client can talk to API gateway in HTTP, but behind the API gateway might want to talk to the services with RPC protocols. And also another example is wrapping the async request as a sync request. So what does it mean? Some of you might have used the purchase functionality in TikTok app or some other apps, which a typical user experience is after your payment, you will see a loader that's keep loading. And after a while, you see that there is a result come up to tell you if you have successfully purchased or failed. So this entire process is, it looks like sync experience because you are waiting in front of the screen. But in the backend, it's composed of multiple requests instead of the single request. All right, then the next, the most important components is the microservices. So the services, as the name suggests, is micro and each only focuses on its own business domain. And it's the business handler to serve a very particular specialized business needs. We shall see some industrial example in the last section. Let me move on to the benefits of moving on to this architecture. So compared to the traditional monolithic way, we can see that the system is now more resilient. Why? Because all the functionalities has segregated deployment. So I have my gifting service deployed on one node and my video service deployed on the other nodes. Let's say if the node itself fails and it does not affect all the functionalities within my app. And if the service itself fails, let's say there is an issue in the code, it will also contain the fault within the component itself. So in a sense, it is a bulkhead design pattern. So the bulkhead is a section on the ship. So in the ship, normally, let's say if there is a hole in the bulkhead itself, then the water will only come in into just that section and your boat will not sink. So that's the concept of the bulkhead. And also the second benefits is the system will be very scalable because all the components are just small and easy to maintain. Scalable in both sense of the deployment and also the evolvement. Small services means the code base is small and we can have a very specialized team just to focus on one component and make it the best component. And whenever we want to add on some features to one of the components is independently from the other, and we can work on a lot of features in parallel. And in the deployment sense, let's say if a particular component has to serve large workload, then we can choose just to scale out this component individually, and we can just optimize the resource usage. And the next point is on the independence. So because the services are broken down, they are loosely coupled. And all the services communicate with each other through well-defined API because they are deployed individually. So the APIs can be a RPC interface or HTTP interface as up to the choice that you like. And also it allows polyglot programming, which means the services does not have to share the same technology. So you can code your one service in Java, the other service in Golang. They will not affect each other because the communications are remote. In order to support the microservice architecture, the TikTok company has came up with an infra support support suite for that. So basically, it contains a number of sidecars, and also the sidecars are decoupled from the business deployment. So for those of you that are more familiar with the Docker container technology, for example, the Docker, the Kubernetes, you can take the big box outside, the white box, as a pod. So a pod contains a set of containers. So each sidecar is a container by itself and contains a lot of cross-cutting technologies required for every microservice. A typical component is the agent. The agent, some of the main functionality provided includes the console, the metric, and log. So what is console? You might have heard of this product or in the open internet. So basically, this is how the services resolve the address of each other. So if you have studied the networking concept, whenever a service wants to talk to the other, it has to know the IP address of the other service. And because your services will not only deploy as a single instance, since the IP to instance mapping is 1-to-1. So it's not possible for your client to remember all the IP address of every single instance. That's why we need a console here, which it resolves the IP address using something else, similar to the concept of the domain name, so that the client only has to know a single domain name and it does not have to know what is the actual IP address that it resolved to. And for the second component, the metric, the system needs to be observable. So it has to emit metrics on how it performs. So whenever there is irregular issues, we can detect with the metric data emitted. And for troubleshooting, by looking at the metric, we will be able to locate the issue fast. So there will be agents that's in charge of collecting all the metrics and send to our metric server. And the next component is about logging. In order for the troubleshooting purposes, every service has to produce some logs. So the logs will be collected by the agents and sent into a log server independent from the business process. If any of the components in the sidecar fails, it may or may not affect the business service. And also we have a match proxy components that's in charge of centralizing, encapsulating all the low-level network implementations within it. For example, if there might be some optimization to at the serialization or deserialization level for communicating between the two services. And let's say if we want to implement the zero trust communication, which means the service does not trust the other service, and there has to be some signing and authentication in the process, then it can be encapsulated in the mesh proxy by itself. You might be heard of this two-way SSL in a sense to implement that. So that's what the proxy does. All right, I think I have left a Q&A session over here.
Yeah, so Binxian, there are quite a few questions on the Q&A. Shall I read them to you?
Okay. I see that there are 6 questions. All right, so the first one is, are reverse proxies and proxies the same thing? Otherwise, what is a reverse proxy? So the reverse proxy is not the same thing as proxy. So generally, the proxy has 2 categories. One is called reverse proxy, and the other is called forward proxy. So let's say if you want to play some game in a region where your network is being blocked, so you might want to connect to some proxy to do that. So this is the case of the forward proxy. And for the reverse proxy, the functionality is to hide the backend IPs from the public internet so that the public client only interacts with the proxy and it does not know what is the actual backend services behind it. Yeah, basically that's a very generic difference between the two. Okay, what happens if the API gateway itself goes down? Does that not fall prey to failure in one causes failure overall? Okay, good question. So that's why this is another question that we have to resolve. The API gateway itself is in order not to make it a single point of failure, all the products will be provided in high availability, which means there will be a big batch of machines with API gateway service deployed on everybody. So let's say if some of the machine goes down and we still have some other machines that's able to take up the load. Okay, next question is what is the difference between reverse proxy and the load balancer? I think for the modern products, they're almost the same. For example, for the Nginx, it does the work for the reverse proxy and also the work of load balancing. I would say the reverse proxy is more like description of the functionality instead of a product by itself. So Nginx is a product that serves both the reverse proxy functionality and also the load balancing functionality. But it refers to different stuff. So basically, reverse proxy is more focused on the routing logic, the resolving to the backend services. But the load balancing is more focused on how to balance the load, and there is a lot of strategies out there. A simple one would be round robin. Okay, the next question is about what is the difference between load balancer and orchestrator? So the load balancer, we generally refers to balancing the network load, but the orchestrator is to balance the deployment of the service on the machines. So it's to balance the physical resources such as CPU and memories. Hi, can I ask why is there a reversed service in the diagram? Sorry, I don't quite get it. What do you mean by reversed service in the diagram?
Maybe for the person who asked that question, you could elaborate a little bit more in the Q&A. It's on the microservice diagram.
Reversed service. Oh, do you mean the arrow from the service on the right hand side that points to the service or to the left hand side?
DevOps pointing to service.
Yeah, so basically this is to illustrate that the services can talk to each other as well. Yeah, so it's not a reverse service, it's just that intercommunication between the services. When would you use a monolithic architecture? So let's say you are doing a very small project, you can use that. I would suggest. So basically, it's a trade-off between the effort quality and also the the cost. Yes. So let's say you want to build something within 1 day itself, then of course you have to choose a monolithic architecture. All right, the next question, could you recommend some online learning resources for your topic? Online resources. Yes, I do. I think there is some reference in my slide. I think it's on some next slide. Yes, I have put out some reference on my very last slide. I can share later.
Yeah, they would have access to your slides as well on the Tech Immersion webpage, which we have made public.
Oh, all right.
Mm.
Okay, so the next question is, so reverse proxy is like an API gateway design pattern. I would say the API gateway has more functionalities than a reverse proxy because you can build up very specific stuff that's only required by your own system. So for example, in TikTok, we have our very own ecosystem of the user authentication. And we need to have a dedicated resolver to support the authentication. Then that can be built into the API gateway layer. But that's not commonly used outside. Yeah, reverse proxy is more referencing to the network related functionalities. All right, so the next question, does a console store the DNS together with the IP addresses for DNS lookup? Yes, it does. So it store the, you can think of it similar to a domain resolver. It's a similar thing. So TikTok doesn't use Kubernetes, but fully uses its own orchestrating system, ByteMesh. ByteMesh is not an orchestrating system. It's more like to governance your the ingress and egress network. We do have some our own orchestrating system, but I think that also references part of the implementation of the Kubernetes, but yeah, there is customization included. When is microservice architecture overkill? I think again is based on how micro you want the service to be. And for the microservice architecture, the design decisions is very different from how you build a monolithic system. You have to think about how do you break down the system to make it that not too small and not too large. Yeah, so this is a design decision. I will be going through this in the very last section of the industry example to show you. Okay, the next question is about, I understand the single failure point in a monolithic architecture, but if a microservice has a huge bug or fails, wouldn't it affect the rest of the system that depends on it as well? So again, this is a design decision. So as I mentioned earlier, there are a lot of design concepts out there to isolate the failures. So one of it is the bulkhead failures. So whenever you want to break down a service, you have to think about how the service, if one of the service fail, it should not bring down your entire system. A very simple example is there shouldn't be a cyclic dependency between your service. So let's say I have service A, B, C, but my service A calls service B, which calls C, but C calls A again. So let's say I want to deploy A, then it might cause bring down the entire system because the C is also depending on A. All right, for the next question, does backend engineer needs to know the stuff of orchestrator, or it is more that towards the cloud engineer? I would say it's good for the backend engineer to know, because you have to be aware that there is a layer between your services. So in the troubleshooting process, let's say there is a network issue, you have to know what are the middleware inside. So a common question I ask in interview is like when a front-end engineer tells you that the API can't be called, how would you guide him to troubleshoot that? So in order to answer this question, you have to know the middleware in the first place. So let's say, so we can break down the link step by step. So first I would check for the ENS resolver. And next I would try to check if the TCP works okay. And if that works okay, I will be checking if my CDN, the reverse proxy, works as well, and if the request does hit my backend services. Yeah. Sometimes when we encounter the network issue, it's related to the middleware in between. Okay, next question. How many microservices does the TikTok Live feature consist of? I don't have an exact number, but it's very enormous. It's an enormous number. Yeah. Okay, what's the difference between API gateway and API? So API gateway is a networking component that contains custom application logic to serve the API, but API itself refers to the definition of the API, the request response for those. Yeah. And just refers to the interface definition. So the ABC example you gave in that earlier question, are you referring to a deadlock scenario? Not really, it's not related to the locking, but because the lock is usually when you are acquiring the same resources. But for this is the three services serves for different purposes. However, there is a cyclic dependence. So let's say the A has an issue with one of its API that is consumed by C. When deploying A, it will bring down the C's business functionality while it should not. Okay, sorry about the slide on byte mesh. Is it saying that the byte mesh utilizes sidecar, which consists of the components like agent, mesh proxy, etc.? Yes, the components are deployed as the sidecar. But I think some of the components might not be the sidecar approach, but more of the daemon approach on the node itself. For example, the metric and log. For those of you who have played around with the container technologies or the AWS, what was that service called? Some elastic container stuff. Yeah. So basically, there will be some daemon to help you to collect the metric and log, and you have to install that thing on the virtual machine itself. Then all the containers on the machine will just use the same daemon. Okay, given that the TikTok uses a lot of customized technology, what are some things that someone aspiring to join TikTok infra develop DevOps should learn? DevOps, I think there is a lot of the DevOps tools provided by the infra team. For example, the CI/CD pipeline. So basically, there is a whole automated platform for the CI/CD, so that it provides a very good experience for the artists, the developers, whenever we need to deploy the testing service or the online services. And for the online services, the pipeline continues to evolve to have a better workflow. For example, we have checkpoint to check if the unit test, there is automated test integrator, and also there is monitoring node to detect if the error rate or the error matrix arises during the deployment process, then it can remind you to stop or roll back the deployment. And in order to support such things, there are a lot of infra metric standards to detect every single problem in the process. Yeah, so there is a lot of stuff to learn.
So Binqian, somebody dropped a small question within the chat box. Does TikTok normally implement a serverless architecture?
Serverless? No, I don't think so. We have a lot of servers. We rely heavily on the server. All right, I think I will move on to the RPC concept section. So what is the RPC? RPC stands for Remote Procedure Call. Basically, it is a very generic term referencing for all the communications between one device and the other. So you can say that HTTP is a kind of RPC. You can also say that AMQP is kind of RPC. The communication to your database is also a kind of RPC. So generally speaking, the RPC framework contains the following underlying technology. So first is the code generation, so-called scaffolding, because how the RPC works is, first of all, we have to define the interface. It's like when the two persons talk to each other, they need to talk in the same language. Otherwise, they can't understand each other. So the same thing happens between the services as well. But the service, in order to call the API itself, the implementation has to be written in the code that's used by the repo itself. So I have a service coded in Golang. I have a service coded in Java. We want to talk to each other in the same language. Then we need to have a client written in our own coding language. So that's why we need the code generation to reduce the manual effort of typing out all the client, the serialization process in every coding language. So the next part is about the serialization. In the RPC framework, how the packets gets serialized and deserialized can be customized, and there might be more optimization introduced based on a very particular need. So for example, in the protobuf RPC protocol, there is very well-performed compression strategy inside the serialization part. Then the next is, of course, the network. Everything has to be sent over via the network. And also it is up to the choice of how RPC protocol is designed based on a very specific need. For the RPC procedures, it works very similar as any of the others. So first, the client has to construct the request, and then it gets the server address by service discovery. And then you will have to establish the connection with the server, let's say the TCP handshake stuff. And after that, the client starts to serialize the request into the binary packets with compression or whatever inside of it. And then the packets are sent over the network. So next, the server will receive the data and deserialize the data into some request memory object and handle it. Then it constructs the response, and that's the same process to serialize it and sends over the network. The client gets the data and it deserializes the data into the response. So one of the very important concepts in the RPC framework is the IDL, the interface definition language. It is not a coding language, but a language to describe what you need in an interface. So an IDL file contains one or more interface definitions. Generally, you would want to define what are the request parameters, like your function inputs in your API, and also what are the response parameters that this API returns. And also you would need a name of the API itself. So the ideal file supports the language or platform agnostic communication between the server and client, so that each one can just be implemented in its own coding language without relying on what the coding language the other service uses. And then in order to send the request, we have to resolve the server address in the first place. So in TikTok, we use PSM instead of the domains that you know outside. And the PSM is a very custom defined kind of domain-like thing. It consists of product, subsystem, and also the module connecting by the dot. So an example can be tiktok.kitex.example. And this PSM is like an identifier, unique identifier for each microservice, and not only just used in the service discovery, but also in the governance modules. And also in the Kitex code gen tool, the convention will be enforced. If there is an invalid character in the name itself, then the tool will throw error. All right, that came to the end of this small section. There is another Q&A section over here. All right, I see there is a question about, is RPC similar to REST? In the sense, I would say yes. The concept of the REST is about the stateless implementation of the server.